There we go. Beautiful. Look at me remembering to do stuff. Okay. So yeah, the latex question was the only one. Okay, cool. Yeah, I was talking, but there was a bunch of people in my office, so I wasn't actually talking to you, but that's okay. I'm just kidding. Okay. Any other questions about the Jupyter Hub notebook stuff? It looked like everybody kind of figured it out. Not soon enough. No, I'm just kidding.
That's still due at 11 tonight, right?
Yeah. hmm
Okay.
Yeah, yeah, yeah.
Thank you.
So yeah, I pulled as whatever was there this afternoon just so I could like make sure that it was doing what I thought it was doing what y'all thought it was doing. You know what I mean? Um, so I will pull it again tomorrow after the due date, and if there's anything that's needs to the grades need to be updated, I can do that too. I'll do it like after then. You know what I mean? Does
Yeah.
that make
Thank you.
sense? Okay, yeah, no problem. Like I said, I hadn't really I wasn't sure if my stuff was gonna if it was gonna work, so I wanted to like get a heads up before class. So, and then I had some people be like, "Did I get it?" And I was like, "I don't know. Let me try." Okay. There we go. Let's see, meeting. Everyone seems to be here. Okay, awesome. Cool, cool, cool. Yeah, with neither one of you. Goodbye, my friends. Okay. Oh, I forgot to get you guys some Python refreshers. Oh, I'm terrible human. That's okay. I'll get better at it. I'm gonna write myself a note this time. I don't know, everyone's Python, the advanced Python, it looks really good. It looked really good. Wasn't too bad. Okay, so next this week, we are going to start looking at descriptive statistics. So at the end of last time, I had kind of shown everybody how to load in that data set into the Python. So from here on out, we're going to assume that that's happened. Okay. So if you had a problem with that, let me know. It's in the previous lecture slides, so you can see it there. Okay. But we're going to go through some of the questions for problem 2 today, and then the rest of them on Wednesday. Um, just kind of like an outline so you can kind of understand where we're going. But again, it's going to assume that we loaded that data set into the Python already. Okay. So the first thing we're going to talk about is probability versus statistics. And probability is the framework that gives a reason of the likelihood of something happening. So it's the chance of it happening. It's the likelihood of some future event. Theoretical consequence of the mathematical definition. Okay. So the probability is we don't know until after it happens, but we're guessing what's going to happen. Okay. I pick a card. What is the probability of it being a red card versus the probability of it being a black card? Okay. I can't verify it until after the event has happened. That's the probability. Okay. And your probability goes between 0 and 1, or it could be a percentage, which you would multiply by 100. But for the most part, it would be like a zero point 0.5 probability. Okay. Or 50%. Um, so when you sum up the probability of all the different choices, the total adds up to 1. So if I have two choices, it's zero point 0.5, zero point 0.5, it's 50-50. 0.5 plus zero point 0.5 is 1. Okay. Now, statistics, on the other hand, is a way of explaining data you already have. So it is collecting and analyzing large sets or large quantities of numeric data. Okay. So probability and statistics are different. Okay. Statistics are used for the purpose of finding the probability or making an educated guess. Okay. You are using applied math. This is that mean, median, and mode, standard deviation. You probably heard some of those before. Okay. That's statistics. It has already been observed, and so we're actually doing the analysis on the data. Now, remember, probability deals with predicting the likelihood of an event happening in the future, while statistics tells you what has happened in the past. Okay. Probability is more theory based on mathematics, whereas statistics is the applied mathematics behind the probability. Okay. So that's kind of where we're going. So what we're going to be looking at now is more of the descriptive techniques. Nope, descriptive statistics. Now, compound events and independence, we're going to do a little bit diving into statistics before we apply it into Python. So, suppose half my students are female, half are male. If half of my students are above the median, what is the probability a student is both male or female and in group B? Okay. It's the union of where those two events happen. Okay. Independence means there's not going to be any type of correlation between those two. Okay. Independence is hard to predict. Okay. It's easier to predict something if there is a correlation because you can expand that correlation into the future. Okay. So again, statistics, when we're going to look at Python, we're going to look at describing and interpreting data that we already have. We're going to look at math that we're applying to that data and also possibly graphics. Okay, a graphical representation. So there's two types of statistics we're going to look at. The first one is descriptive, which is this week, and next week is inferential. Okay, so descriptive methods of describing characters, it's going to help you make sense of the data, makes the data easier to understand, the average, the range, the shape, the mean, the median, the mode. Okay, can you close the door or like close it like crack, just leave it cracked. Thanks. Inferential statistics, we are going to be able to the inferential is what you infer, right? The word is right there. So it's going to be a little bit more generalized, and you're going to generalize greater populations from the samples. Hypothesis testing, finding relationships among variables, and drawing conclusions about a population by looking at the sample. Okay, so population versus sample. When we look at data, right, we can't gather data on 100% of what we're looking at. I want to know the how females majoring in psychology, um, what age they retire. Let's go there. Can I find every single female who has majored in psychology in the entire world and ask them what age they retired? Absolutely not. Okay. Oh, Lord have mercy. Why do I always do this? Okay, I'm gonna stop touching things. So that would be your target population. Okay. Now, of that, there's a subset of the ones I want to study. So maybe I want to study that are within the United States. Okay. That would be the study. Well, my goal is to get a sample of the study population that I could then create, extricate data to make generalizations about the study population and then possibly the target population. Okay. So my population is the entire group where my sample is a representation of that full target population. Okay. Probability is derived from your statistics. And your statistics is nothing more than metadata. It is data about your data. It's giving attributes to data to possibly find a correlation, find something that exists that will help me describe that data. Okay. So again, we're going to start with descriptive. So we're going to talk about describing or summarizing the data, evaluating visualizations, transformations. Okay. That's what we are talking about when we talk about descriptive statistics. Okay. So the first one we're going to look at is mean. Okay, we're going to go through the mean, median, and mode and all that kind of good stuff. So, central measure is the mean. So, to calculate the mean, we sum the values and divide by the number of observations. Okay, so what's another you can put in the chat box? What's another word for mean? You sum them up and then divide by how many you have. Yeah, average, exactly. Okay, so the average tells us kind of like what the center value, not the center value, I'm sorry. The average is going to add them all up and divide by however many there are. Okay, so if they were all given equal weight, what would that be? Okay, so for example, what is the mean body temperature? 98.6, right? That means that some people's resting body temperature might be 95, some might be 99, right? This does not mean every single human has a resting body temperature of 98.6, right? It just means that's representative. Everyone's kind of around there in that general area, okay? What is the mean IQ? Well, it's 100. That also means there are people that are much lower than that and people that are much higher, okay? So the next one, I'm flipping my paper, I'm sorry. The next one we have is our variance or standard deviation. Okay. And what that is nothing more than the standard deviation is like how off am I from what is considered kind of that central location. Okay. My variance is equal to the standard deviation squared. And typically, typically we'll say it's the standard deviation of the population or the sample. Okay, the standard deviation um, population divides by n and the sample divides by n by 1. Um, but as I get huge, it doesn't really matter, right? So if my sample is 2, 2 minus 1 is 1, that's half, that's a lot. If my sample's 1 million or 1 million minus 1, I don't have such a great impact anymore. Okay. So we are talking about that big data. So we are talking about these large numbers of n. So in reality, this n or n minus 1 doesn't really matter. Okay. So I do have an equation here just for equations. It's the square root of the summation of x minus x bar squared, which x bar is the the average, right? So it's how far I am from the average square divided by however many I am in the square root. So it's the average distance from the average number. Okay. So it's how far I am from the average. Okay. So standard deviation is the average distance of the data points from their own mean. So this will change based on the mean, based on the sample, right? Because the mean changes. When the mean changes, this will change. Low standard deviation means that the data is clustered around the mean. Okay. So it's not very far from that center. Now, if it's a high standard deviation, it means that they're very far away. Okay. So you can kind of look at this. This is a more normal distribution. This, I would say, has a low standard deviation because it is clustered in this central area. Okay. This, because it's exponential, so the mean is probably right around here somewhere. And oh, look, I have pictures. My mean is 1. Here, my mean is 1 as well. So this right here, it's not really clustered. It kind of goes out to the side. So that standard deviation is probably going to be higher. Okay. But something else that I can see from this is the shape, right? I've got a shape kind of based around my mean, whereas here it's kind of it's symmetrical, or in this case, it would be non-symmetrical. Okay. And I can describe this shape based on the mean using skewness. Okay. And skewness is just how evenly distributed amongst the mean. I'm like all caught up in chords. How it's distributed amongst the mean. What does the shape look like? Okay, so here, a skewness of 0 means I have perfect symmetry. That is my perfect bell curve. That is the one I want to try. Okay, that's what my goal is. My goal is the bell curve. Remember, okay? That being said, it can skew either to the left or to the right. Okay. A negative is going to skew to the left, or it's gonna negative values are going to skew to the left, which means it's going to be right modal, which means the mode is in the right. So it's like that flippy thing. Sorry, my brain had to catch up. Positive skewness means it's skewed to the right, so it's left modal. Okay. There's another equation for skewedness. Our nice thing, these are all going to be built into Python and we're not going to care. Okay, this is more of a review of what these terms mean so that we can use them in our data moving forward. Okay. So my skewedness formula, I've got 3 times the mean minus the median divided by the standard deviation. Well, okay, we've done mean and standard deviation, so let's hop into median. Median is the middle value. It's exactly half of the data are above it, half the data are below it. Okay. Mean, median, and average are sometimes confused. Okay, so mean is the average. Median would be the halfway point. Okay. It is useful more in statistics than anything else because of what it does tell you. So if I have exams that are 0 to 100, if I tell you my average is a 23, but my median is 12, that means most people scored between 12 and 100, and the same number scored between 12 and 0. Okay. So it gives me a little bit more, a more clear indication of where I'm at in the range of all of the sample, more so than mean does. Okay. Average sometimes doesn't really show you what it is. Okay. Your median is going to take your outliers into effect, whereas your average doesn't really tend to do that. Okay. All that average is going to do is kind of mess with the outliers are going to mess with the average. Okay. Median is used a lot more when your data is non-symmetrical. Okay. Your mean is going to mean a whole lot more in a symmetrical data distribution than in non-symmetrical. Okay. To find the median, you first thing you do is you have to make sure that they are ordered. And then you find the center. So if I have 20, I want to find which one is around 10. So if it's an even number, the median is the average of the two that are in the center. Yes, they're in here. Who? Okay. Nope. Can't get people to leave me alone. Okay, median. So remember, first thing I have to do is order it. So if I have a list in Python, the first thing I'm going to want to do to find the median is I am going to want to sort that list. Okay. Then I want to find the one that is at that central position. It's a single number if it's an odd number. It's going to be an average of two if you have an even sample size. Okay. Quartiles. I don't know how to say it. I think it's quartile. That's the only thing that makes sense in my head because it goes with quartiles and percentiles. So maybe it's quartiles. Quartiles. Anyway, it's how far off the median you are. So if you're looking for the 50th percentile, it would be right at the median. If I went 25% on either side, it would go 25, 75. Okay. So now what you're doing is you are taking that distribution and dividing it up. So your very last outliers on either side is 0 and 100. Then you take that distribution and divide it in half, and then take those and divide it by half. And that's what's going to give you the 25, the 50, and the 75th. Okay. But what about something like these? Okay, so I've got a single and a mixture of two. So everything technically is the same of what we talked about. Okay. The mean, the median, the mode, the skewness is the same because they are symmetric. So be careful when you're looking at statistics and you're not getting the whole picture, okay? Because again, it's data. We can almost make data say absolutely anything that we want, okay? So let's take a look at Project 2, Descriptive Statistics, okay? Remember, we're going to assume that we have imported that adults.data file into our Python when we start. Okay, so just as a little recap, I've got a flat file. It is a comma delimited file, and it has all kinds of data in it. We went through what the data was last week, um, and we kind of started out with this snippet of code. Okay, this is already in the project 2, is the code and stuff is in there, so you can kind of go through it. So down here, we opened my file. We created a function that converted a string or a character to an integer. Because remember, when we read in, everything is a string. So we have to force it to be a numeric. Then I created an empty list data. And then I went through line by line in the file. I took the line, I stripped it, I split the line on the commas, and added all of those items into my list data. I did it as a dictionary entry so that each column has, think about it as having the column title associated to the data. So for the first one, I associated the word age, the type employer, uh, I don't remember what this one was. Final widget? Sure. Their education, their education number, their marital status, occupation, relationship, race, sex, capital gain, capital loss, hours worked per week, country, and if their income is greater than 50K. Okay. And then I close the file because remember, don't want to keep files out there lingering and open, just good practice. So all I did in here is I got all of this comma delimited stuff separated, associated, and put into the list. Okay. The very first question that the project asks is how many people are represented in that data set? Okay. Anyone know how I can figure out how many people are represented? What would I put? Well, I could take the length of my list, right? Because my list has a row for each row of data. Okay, so I can just say num equals 0, num equals the length of that list. Does that make sense?
Yeah, that makes sense. That makes sense.
Okay, okay. I just want to make, I need
I
some
don't know. I have
feedback, y'all. Yeah, go. Go for it.
so if hmm. So you're just taking like the amount of rows, like not necessarily like
Yes,
going down the columns, just the rows. Okay.
correct. Because how many people, if I go back to the data set, each row is a person. The columns are data about that person, right?
Yeah.
So if I want to say how many people are in the data set, I just need to know how many rows there are.
Okay, yeah. I just made it more complicated in my head. My bad.
I got you. No, we are IT. We tend to do that. Not gonna lie. Okay. So if and when you'll get around to it, there's 32,561 people represented in our data set. Okay. So if that gives you some kind of idea of the volume of the data that we're talking over 30,000 rows of data. Okay. Not something you would want to go through in an Excel spreadsheet. Just putting it out there. Okay. Any other questions on question number one? Okay. Let's move to question number two. How many people in each country represented? And the hint says to write code to answer in the form of country subcount and store it in the variable country count. Okay. Now, there's a few things we kind of went into this with the advanced Python. Remember, there was like a slick way it was like at the very end. Let me see if I can find my notes. It was at the very, very end, and what did we say? We said that I can't find it in my notes. I'm just kidding. I am, but I'm not. Okay, here we go. So a common task in data science is to count all the occurrences of a particular word. Okay, so our example we used last week was to count all the words like in a book or story. Okay, so what do I need to import? Well, that's the collections. Okay, and in that, remember, collections will automatically initialize based on each key, the count. Okay. So remember, we did this two ways. The first way we did it was for every word in the document, if the word exists, add one to it, else set it equal to one. But with that collections, I was able to reduce that down Into for word in document, I just add one to the list. Okay. But I had to do it by using the default dictionary function to give values for the keys that do not exist. So to do a count, we will say counts equals collections dot default dictionary int, because we're going to count it with integers. Okay. And then we're going to count up the number of each country. Okay. So we're going to pull out all of the unique values in country using this default dictionary with the collections. And then we're going to loop through my data set row by row and add a count to the country of that row. Okay, and we're going to do that 32,000 times. So what does my code look like? Okay, so first I have a country count, which is just going to be a dictionary. I'm going to import my collections because I need to do that in order to use this default dictionary. Okay. And then my country count is going to be equal to collections dot default dictionary, and I'm going to have an integer. Okay. So far, so good. So that
So this
collections,
one,
go for it. Yes, question.
so this one's just kind of the total amount of countries, not necessarily like total amount of people for a specific country.
It's doing both. So from what I
Oh,
just said, it's only count. So lines one, two, and three here are only pulling out unique countries. This for loop will add to the count for each person. Does that make sense?
oh, okay. Yeah, got
Okay.
it.
Okay. Yeah. So for person in data, so now I'm going row by row in my data, right? My country count sub person equals country, and I'm going to add one to it. So of my country count, if that country says United States, I'm going to add one to it. If that country says Cuba, I'm going to add one to that. Okay. That's how it goes and gets the count of people from each of these countries. So out of the 32,000 records that I have in that data, I've got 29,000 in the United States and I've got one from Holland. And then the rest are somewhere in between. Okay. Does that make sense? We're doing good so far?
Yep.
Okay. I'm going to hold you to it. Okay. Oops. I gave you the answer. No, I'm just kidding. Okay. So the next couple of questions, it's asking for some descriptive statistics in four different areas. Okay. So it wants to know uh, males, females, and then what they're considering rich males and rich females. I don't know. I find this a little weird, but that's okay because we don't care if they're rich, do we? I don't know. We might, but somehow it made sense in someone's head. So males, all males, so sex equals male. All females, sex equals female. Rich males is going to be sex equals male. Income is greater than 50K. Remember, 50K was like one of those column titles. It's the very last one in that common delimited file. Okay. Females is going to be sex equals female and income greater than 50K. Okay, so the first step is to make four different lists. We're going to make a list of the males. We're going to make a list of the females. We're going to make a list of the rich males and a list of the rich females. So we're going to go through that list data and we're going to basically sort them into male, female, rich male, rich female. Okay. So we're going to do that by for X in data. So we're going to go through that list of data, which goes through the rows, each row by row. If X, which is the row, send it the dictionary of sex. If it is equal, right? Because it's comparison to male, I'm going to append the row to males. Okay. Easy peasy lemon squeezy. Okay. We look at the row. If the row says it's a male, we're going to add it to the male list. Now, a lot of times in Python, though, this is too many lines. Okay. We talked about doing list comprehension at the end of last class. So instead of saying these three lines, I can combine them. Remember, we basically take this last thing and kind of put it in the front, and we use a whole lot of brackets. Okay, maybe you'll remember this. Males equals X for X in data if X of sex equals male. Okay, I think what did we do for this? We did like an XY. We did the squares. That's what we did. We did squares equals blank, and then we did for I in range, squares dot append. Okay, because remember, I'm only doing one step here. So I can actually kind of take this, move it to the front, and then kind of put it into the list comprehension version. Okay. If you're not understanding the list comprehension, kind of go back to what we did in the advanced Python and you can go backwards because we're going to be looking at it in this way. And I think one of the very last things we did is we looked at it kind of backwards. It was like an XY coordinate pair. You can look at it that way, okay? So in a similar manner, I can write one that says females equals X for X in data if X quote sex equals female. And it will put all the females and sort it into that list. Okay.
Dr. Gentry,
Yeah.
I have a quick question. If it was a
Mm,
situation where it was like, say, a nested for loop, would you be using two X's in that one line, or would you be separate? Or am I over
for
analyzing this?
the second one?
Um, no, like say like a different like scenario. If you have like a nested
Oh,
for loop,
okay. I'm like, where are you putting this in here?
oh, I'm just
Okay,
like have like
gotcha,
different.
gotcha, gotcha.
Sorry, my bad.
No, that's okay. Because I was like, wait a minute, because sometimes this X for X over here gets confusing. Um, but you're saying if you had a nested four, so if it's like four and then four,
Yeah. Hmm.
I think you would have to have like one of these in the innermost and you would have to do a four on the outside or just put more brackets around it. I think that would start looking funky.
Yeah. All right. Never mind. Forget the other question. Thank you.
I love it. That was great.
Appreciate it though.
That was
Thank you.
great. That was great. Yeah, because like for this, yeah, so I'm trying to think. Well, wait a minute. Go back. The example we did with the XY coordinate pairs had a four and a four. And it literally said like 4x, blah, 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 4y, blah, blah, blah. Go look at that example we did the last class on Wednesday. The very, very last thing we did. That was a four with a four.
Okay. Thank you.
But it does look funky. I stand by that one. Okay. So now I've broken off all of the male values. I can do the next thing I need to know who's rich. Why? I don't know. So instead of looking through all of the data, let's put on our thinking caps and let's just look at the males because I just want rich males. So I can say my rich male list is going to be a subset of the male list where my income says that they make greater than 50K. So X for X in males, if X is income greater than 50 is equal to the string greater than 50K. Okay. So that way I don't go through the 32,000 records. I go through however many were male. Okay. You're going to go through this same exercise, but for the females. So what you'll end up with is females equals X for X in data if sex equals female, and then rich females equals X for X in females if X income greater 50K is equal to greater than 50K. Any questions on going through those lists and sorting them how I want them? Any questions so far? Okay, so we'll get that caught up on question two next time on Wednesday. We're going to take those four lists that we have and we're going to do more statistics on it. Okay. So we're going to look at min and max versus the actual mode and some correlations that we can create between those. And then we're going to look at something called a correlation coefficient. And in particular, we're going to be looking at Pearson's R value and the Spearman, I think it is. Yeah, the Spearman rank. Okay, and we're gonna implement some of that, and some of the stuff we did today on our question number or on our project. Yeah, project two. Okay. Any questions? Did I hurt you? In a, I don't know. That sounded terrible. Did I break your brain? Okay. Johan, how may I assist you, sir?
Um, I'm not really asking any questions about what we learned today. I think you did a good job at explaining,
Okay,
but
good.
I just have a concern.
Yeah.
So recently, we know we had the lab, right? And
Yes.
um, since I did join the class late, like right after it started,
I noticed I added you today.
yeah, you added me today. Okay, good because I
Yeah,
couldn't.
I'm so sorry. I did not realize until today that you were not there.
No, no, no problem. Yeah, I was just checking. Yeah.
Okay. If for some reason you can't get the project one completed by this evening, just let me know.
Okay.
And if for some reason it won't let you submit it or whatever, just let me know. But I did not notice that you were not in there until today. So I
Yeah, that's
apologize.
fine. I was just checking because
Yeah, nope. That
no
was
problem.
totally on me. Whenever they sent the class list to whoever the dude is that loads that all up, you weren't there yet. So, like I said, I only saw it today when I was doing some of the grading stuff. I was like, uh-oh, this person doesn't exist. So you should be added now. I did it this afternoon. Okay, but just keep in touch with me, in case you have any other issues, okay?
Thank you so much. Appreciate it.
Yeah. Okay, any other questions, comments, concerns? Okay. Was going through some of the project helpful?
Yes.
Okay. Yeah, I didn't do that for the first project, and I think you guys figured it out, but I think this will be really helpful for us because it makes that connection between, otherwise you don't get that connection between the Python and like the theory behind it, and theory is boring. But if anyone asks, it's awesome, right? Um, but I want you to get like the practical out of it. Okay. Well, that's all I have for today, my friends. If you need me, you know where to find me. Just don't email me because I'm just really bad at email. I'm better at Discord. And I will see you all on Wednesday.
Thank
Thank
you.
you.
Have a good
Bye.